Ladies and gentlemen, boys and girls, for creatures from all around the world, or some crap like that. Anyways, today we are gonna be taking a look at the fourth crackme that I wrote for crackmes.de way back, like 10, 12 years ago, something like that. And it's that's not it. Or is it? That's not. There it is. So right here is the one that we will be working on. I wish I could move stuff, but whatever, that's okay. So, you have a please register to continue JLJ. Password. Wrong. Alright, well, that's no fun. But let's open it in X32. See what happens when we do that. So I'm gonna try to make this big enough everybody can see it. Let's just go like this. Open desktop. crackme 4. Alright, so we land right here. Now if we just try to run it, so we can get to like name or something, let's see what happens. Okay, it says running. Okay. Everything went blank. Let's hit rewind. Wow, this will be fun. Okay, rewound. Let's try olly. Try that. Let's try olly. Let's see what happens with olly. Stop. FJlj. Where is it? Not on my stuff. Nope. Somebody else. Alright, let's hit run. Oh, well, what do you know? There's some breakpoints in here. Somebody's been working on this. Let's just go delete, 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 delete. There we go. So let's hit run. And everything washes out. Got nothing. Okay, let's hit X. So clearly it's not an olly versus X32 DBG problem. It's clearly some anti-debugger disassembler problem. We're going to close this, crash olly, and get out while we still can. We're going to hit stop on that. What happens if we attach to it? Maybe we can run it and then attach to it. Maybe. Try that. Name fjlj. Let's try attaching to it right here. Okay. We're in ntdll somewhere. View modules. Okay. Is it still running? Hey, look, it's still running. We've attached to it successfully. And right here looks about right. But I want to do a pause. Oh. It won't let us pause. Yes. Enter. Wrong. Press any key to continue. Can't pause it. Can we search for strings? Here's fjlj, you suck, I wish, you suck, I wish, you suck, I wish. Here's a key we put in. Let's see where that's being referenced. Okay, this looks promising. Gonna analyze. Looks pretty heavy, but here we go. What calls this? Go reference it. So that calls it. Wrong, pause, right. So we need to end up in here somehow. And if we look, We have a call to that just before exit process, but it's right here. How do we get to here? Because something gets us here. But how do we get to here? And now, hello! Nami and 7-0 to XP and Olly Valley. You're very welcome. Thank you for watching. So, what I want to actually do, now of course I wrote this, but of course it was also 10 years ago or more. I want to hit rewind. And what we're going to do is we're going to step through the program one line at a time until we find what it is that we're looking for. Because you still haven't found what you've been looking for. Yeah, that's an obscure song reference. Okay, so first things first, let's scroll on up. Find our C exit. Go to the one above it. Press enter. That's beginning of code. We're going to breakpoint right there and hit run. Alright, now we can step through our program. Let's hit F8. And this is just setting up frames and crap like that. And then it does some subtraction and then it calls this. So let's see what this does. This is going to... who knows? We don't really care yet. We'll hit F8. And now we see that we're going to load the string ntdll.dll onto the top of the stack, and we're going to call getModuleHandle. And then we'll see that we are going to be calling... oh, there's some notes in here. Interesting. Well, we're going to be pushing EDX, and EDX is this guy right here. And if we were to follow in disassembler, we'd see that that's just a bunch of zeros. And I gotta go let a dog out real quick, so I'll be right back. Drop anything? All right. So, and then we see down here we have a call to get proc address. So we are pushing EDX, and then, which is just going to be some memory. And then we are going to move to the top, not the top of the stack, but the second from right here. The string nt set information thread, which is stored, and we're going to be getting the procedure address of it from ntdll. You'll see that right here. So what is this program going to do with that? So we know that we loaded ntdll. Well, we got a handle to ntdll. And then we got the procedure address for nt set information thread. And then let's just go ahead and open up Chrome here. Nt set information thread. Let's take a look and see what that does. Undocumented functions. Fun. I like undocumented functions. Zoom in a bit here. So we give in a thread handle, the information class, the information, and the information length. Okay, so we have a handle to a thread object, open with thread set information access, information class to set to, see thread information class for detailed description of use, pointer to value to set, length of value to set. Okay, so let's go to thread information class, and let's see what these are. We'll just save that for later, because we have a procedure address for that. It's currently in EAX. We're going to subtract 8 from ESP. Great. Making up some space. We're going to move to EAX, because EAX is about to get overwritten. Ina Geldiag. Hey, I tried it. It can detect the debugger. Yes, it can. And that's what we're going to have to figure out how to get around. It detects the debugger several times. When I wrote this crackme, I was like, how many ways can I detect that the debugger is present? Go. It even produces different keys if you're in a debugger. They'll show up valid in a debugger, but when you run them outside the debugger, they won't work. So yeah, we'll get there. So we are going to get the current thread. That's going to now be in EAX, and the current thread is -2, or that. So we're going to push a 0 down there, and a 0 just above it. And then an 11, set information thread 11, OX11. And then we're going to move to EAX, our thread, and we're going to call that NT set information thread. And I bet you anything, if we call that, it's going to break our whole program. Let's see what 11 does. Buffer size 4 bytes, value, ulong value. Now, let's see here. Let's see if there's a better site for this, because this one... thread information class. I want to know... Oh, come on, let's go back. Oh, look at anti-debugging, NT-set information thread. Let's try that link. NT-set information thread, NT-current thread, hide from debugger, debugger check, tool detected. So, yeah, this isn't the one that I thought it was going to be anyhow, but that's an advertisement. But we can obviously tell that it's going to detect the debugger. Let's see here. There was one that I had seen that was very much well written. Told you the different values. Oh, right here. If a debugger is attached and we pass in OX11 to our process, will immediately detach any attached debugger and terminate the process. Let's see. So we know that it's passing OX11, and as soon as we run it, I'm going to hit F8 now. It says running, and it has crasholed. And the debugger thinks it's running, but it's not. It's been forcibly detached and the program has exited. So let's hit rewind. And gee, that note right there might have head us off a little bit. I'm going to start including debug strings in I'm going to write a crackme, and in the debug strings, I'm going to be like, maybe you should jump over this. Alright, so let's go back up to our C exit. Man, there's 8 people watching. 8, you got better things to do than watch me? I'm just kidding. Of course you do. You just chose to be here. What? Why did my breakpoint not work? I'm rewinding. Okay, let's see here. The exit. Okay, we have a breakpoint right here. Put one right here. I'm enjoying my time. Good, good. Okay, there we go. So, we want to let it go ahead and get a handle to ntdll just in case it needs it somewhere else. But then, so we know that this whole chunk here is to get nt set information and then call it. And then we see right underneath it is a check for is debugger present. And it will jump here if it's not. Here if it is. So let's put a breakpoint right here just in case we ever want to see it again. And just like this note here says, it says to jump there. So we're going to jump there. And we're going to do that by doing jmp 401 FOB. And if you have ASMJIT, it's going to say that this is wrong until you put an OX, or you can do xed parse and ext parse, and then you don't have to. It just assumes what you're putting in is hex. All right, so boom, we got that. We're going to be jumping on over down off that now, you see. All right, so let's hit F8. Now, if we were to run from here, what would happen? Well, we're not sure yet, but I can tell you that this section is it's unpacking some stuff, and it's designed to force you to step through it to see all these little help I'm lost and decoy strings. Please register to continue, which is not real. Don't fall for it. It's not real. It's just unpacking some strings right now. And I'll show you that in a moment. Okay, so it's going to take that and it's going to put it somewhere else. And that somewhere else is going to be EDI. You want to see it? We're going to follow it in the stack. And we're going to hit that button. And then we're going to go back and follow it back in the stack again because the stack is always moving. And it's written there, trust me. Let's follow it in the dump and you'll see it. Please register to continue. And if we kind of hang out here, we'll see all of them slowly start to show up. There's name. You see them? See them being written down here? Name and pause. And pass. Wrong. Right. And this is actually what's going on is all of the strings were stored as int pointers. And it's now just essentially casting them, but it has to move them to do it. Jump if equal, all these things. So the decoy strings are referenced here, and then you'll see them later, but they won't be here when you see them. Now this call here might not be something that we want to do, but let's see. Let's hit enter. So it's a call, and if you see there is a note here, and the only reason we know that note is that if we hit F8, let's see what happens. So going to hit F8 to see what happens. All right, let's hit F8. Okay, nothing. It says 1 in EAX, and please register to continue. And it says test EAX. We have a 1. Jump if not equal. Let's see what happens. Seemingly nothing. Hence that word seemingly. Oh man, when I called people out for watching, we lost 2 people. Maybe I shouldn't call people out for watching anymore. Oh man, I dropped it all the way up here. Oh, that was a long reach. Now, for those of you that have taken a look at this crackme already, you're probably following along going, okay, yeah, I've seen this. Now, get to the good stuff. We're getting there. Trust me. So, if you jump over that, and you see that this is going to jump you on up, and you follow that, you see that it's going to exit the program. You've been had. You've been detected. It's going to return, and you're going to be... Watch, I'll show you. Clear it out. Clear it out. Return. And it's exiting the process. You've been had. Boom. Nothing. Never got asked for your name or nothing. So let's hit the old rewindola button. Let's hit F9. And let's scroll on down to where we was. Whoa, scroll too fast or something. That didn't like what I did there. Put a breakpoint right there. Whole number. Anyways, okay, so this time I'm gonna hit run until we hit to that breakpoint. Except here, good thing we put a breakpoint to remind ourselves that we have to do some manual jumping. So instead of jump to, I'm just gonna jump to, which is here. I'm gonna do set new origin here. Boom. No coding required. Run. Now we're here, and instead of doing anything, I'm gonna go into it. I'm gonna go into it because you'll see well, you'll see in a minute. Let's hit F7 and then let's take a look at this. So we are doing what's called set unhandled exception filter. Okay. Let's look that up. Set unhandled exception filter. Now, this is a documented one you can get from MSDN, no problem there. This was a little trick that I thought I'd try out. I came up with there, and what the hell? Uno momento, please. Good heavens. Okay. Sometimes people just they interrupt things, but that's okay. So, set unhandled exception filter. You probably read it while I was away, but after calling this function, if an exception occurs in a process that is not being debugged, that is not being debugged, that is not being debugged, and the exception makes it to the unhandled exception filter, that filter will call the exception filter function specified by pointer top level exception filter parameter, which is right here. So it has one parameter, and it's, hey, call this function over here if it's not being debugged. Okay, so if we are in a debugger and we hit an exception, that won't happen. But that's not the fun part. The fun part is what is coming up. Got to get something to eat, bear back. What if you attach to it after the anti-debugging things are done running? I showed you what happens when we do that. If I had DVR mode on, you could rewind, but right now you can't. Let me show you real quick. I'll just do it. So here's fjlj crackme, and this is past all the anti-debuggery that I know. And let's go to fjlj crackme 4. But PID isn't it. Let's run it again. That one. File attach. Okay. fjlj crackme 4. Okay, this is C78. And we want the one that's not C78. File attach. This one. Okay, we are past all the anti-debugging. It says pausing. It's trying to pause. But as you can tell, it's very much not pausing. Let's just hit run. It won't let us do anything. So let's go options. Let's go to events start. When main start, when attaching, no pause. Let's do that. Okay, we'll hit X. Olly's confused about life. There it goes. Hey, Serbian Phantom, what's up? He says, not much. Just doing my my crackme, the fourth one. I believe you were working on it. And somebody had the question of what if we attach to it after it's done loading. So I told Olly not to try to pause when attaching, and it's still trying. So that's what happens. It says ready, but it's so confused at what life is that, yeah, that's what happens if you try to attach to it when it's running. It doesn't work. So you got to go line by line and see what's breaking it. We found that set thread information was the culprit of that one. And now we are looking at set unhandled exception filter, which is going to go ahead and set an unhandled exception filter for this address right here. Let's go ahead and remember this address right here. So it sets that. Now it's going to grab our current process ID. Boom, it did it. C78. Test EAX, jump if equal, which would go down to here and print, yeah, right. Just a little bit of troll. And now this next bit of code, I want to show you something here. Use Olly Advanced plugin. It has all anti-debugging. And we'll try it. We'll give it a shot. I don't think it will work, but we'll give it a shot here in a minute. Olly Advanced plugin. All anti-debugging. Maybe. So this section here, if it doesn't make sense to you, that's fine, because let's do a quick side-by-side. Let's search for current module, intermodular calls. Is debugger present? Let's go to is debugger present. Alright, so let's just grab a quick snipping tool. And let's go on back. Alright, so what's that code? This is debugger present. But it's just been written in. Instead of a call to is debugger present, it's written in the code from it. Sneaky, sneaky. So now this is going to say, one. One is in EAL, or is in AL. Now, of course, we're going to push ECX, clear it out, move CLAL, move EAX, ECX, and there you go. Pop ECX, put it back, add ESP2C, and return. So we know that this is AL equals is debugger present, which prevents you from getting to what triggers the rest of the code. So we don't want that. Let's go 0. And now we have test EAX. Jump if not equal, we're not jumping. Then we'll see that we are going to move to the stack and address for a string that is JKH, 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 JKH. Say that 45 times fast. Then move to EAX, the D word that's at another place, which is %S. We're going to put that up there. And then we're going to move to EAX by pointer of DS0. And that causes an exception. And had it not, the sprintf would, but this is designed to create an exception. So if we do Control-Shift F8, can we get by it? Nope. Control F8, Shift F8, Control-Alt F8. Control-Shift F9 should do it, but probably not. Nope. So there's your exception. Now what would happen if we weren't being debugged? We would have gone to our unhandled exception filter address, which is here. So let's go to it. It's right here. Let's set new origin here. And we're going to push EDI. Please register to continue. Okay, move that. Move that onto the stack. Move it into EAX. Move that onto the stack. And then call printf. And if we look, now it should say, please register to continue. It does. Magic. Okay. So now if we go down, it's going to say name, move it over, and do a call. So it's overriding things as it does it. It says name, we did a printf, moved EAX a place, move that place onto the stack, moved EAX a place, move that place onto the stack, and then we're going to call scanf. So we want to follow this in the dump. And hit F8. So now it's running. It's asking for a name. Let's hit fjlj. Boom. And All a D-word and dump. There we go. My bad. Forgot to do that. So there's fjlj. Move EVX a bunch of -1. Clear out ESI, move EDI, our name, move ECX, EBX, move EAX, ESI, a bunch of nothing. Now we are going to do repniscasb. Now, if you wanted to know what repniscasb was, we could look it up. Or we could do help on mnemonic, which is garbage. I'll tell you that right now. Garbage. Repni Scaspa in here is garbage. So let's actually go to our good friend Ollie. Let's copy the address. Let's open up olly debug. Let's open up crackme 4. I'm shaking the whole counter, so I'm sorry. Control G, this address, Repni Scaspa. And here it even makes more sense. Repeat until not equal scas byte edi. Let's do help on command. Now, isn't that so much nicer? Searches string for the first byte that is the same as register AL. On each iteration, processor compares that contents of register AL with the byte at address EDI and sets flag COS, ZA, and P accordingly to the difference AL minus EDI. If flag D is cleared, increments EDI by 1. Otherwise, decrements EDI by 1. Register ECX is always decremented by 1. Anyway, search stops ECX after decrement is 0, or if compared operands were identical, flag Z was set. Search stops, otherwise processor repeats the whole cycle again and again until count exhausts or matching EDI will be found. Note that if ECX initially contains 0, this instruction does nothing. So ECX initially contains 0. EDI is also 0 in olly because we're not at that place. So ECX is not 0. It's as far away from it as you can get, which is -1. And EDI contains fjlj, and we are going to be searching for the byte that's in AL, which is 00. So we are going to get to 5. Because the end of this string is going to have a 0 on it. Follow and dump. Look, there's a 0. It's right there. So we're going to hit F8. And what do you know? ECX stopped because we matched. And now if we not ECX, we get 5. Then we're going to take 1 away from that. And we're going to compare it with F, which is 16, and we would jump if it were above it. Now it's not, but you see we would be jumping directly to wrong. Right. So it's not wrong yet, because we are not greater than F, which is a bit of a snafu. I will tell you right now that in this crackme, not every name can make a valid serial. That's thrown off so many people. They say, oh, it's broken. No, it was designed that way to where if somebody's just putting in a name that would not have been handed out with certain restrictions, which you don't get to learn. Sorry, you don't, unless you dig through it and figure out why. But they're not told to you. So there are names that will spit out keys that don't work. And then there are names that spit out keys that work every time. So it's not broken. It's in there by design just to throw you off. I remember doing that. I don't know why. It's kind of a dumb idea. I agree. Looking back at it now, it's kind of a dumb idea. But it will present different passwords if it's being debugged versus if it's not being debugged. You'll see that soon. So now we're going to take EAX, and we're going to shove some stuff in it that says pass. And then we're going to override our fjlj with pass. Then we're going to shove that %s. And we're going to call printf. We're going to call scanf. And we're going to ask for a password. Not that window, that's from Ollie. Ollie, we might need you again, I don't know. Here's a pass, and we're going to put in 137731414. Yeah, sure. Sounds good. Looks great to me. Any questions? Of course you have questions. All right, so move EDI, the D word that is at that place that we told it to write that. So now our password is in EDI. It's going to do the same thing as it did before. Move ECX, EBX, which is still -1. move EAX, ESI, and that is going to be a 0. Now we're going to take a look through it until we find a 0. We found a 0. Now we're going to do that whole move, not, dec, and compare with 1F. So, if your password is greater than 1F, calc, view, programmer, X, 1F, decimal, 31 characters long. Wrong. It's wrong. So if you're at 32 characters long, you're wrong. Jump it below or equal. So 31 or less, you're fine. 32, it goes to wrong. And you'll quickly learn that that means that your name can't be so long because you would end up with a password that's too long. But also the interactions with how the passwords are made, realistically, this number should be 1/4 of that. 7. Users that are 7 or 8 or less should be fine. 8 or more, probably not gonna work. Sorry. Screwed up that check. That should be an 8. I'm new to this. What is the best avenue for learning this type of skill? Studying assembly? What would you recommend? Well, Leroy Jenkins, Pershing, jumping in, taking it heads on. This crackme in general has a lot to learn in it, but basically if you start reverse engineering and you start tearing things apart, you'll automatically start to learn how assembly works. And when you start playing around with different things in assembly, you'll learn slowly how to write it. And then the more you do it, the more you see, the more experience you have, the more Googling and looking up of APIs and different commands you do, the better you get. The more often you do it, the quicker you get better at it. That may sound like I'm dodging the question, but persistence is key. That's the short answer. Just do it. Nike's really onto something there with their whole logo, just do it. Everyone is their own worst enemy. But yeah, I'll tell you right now that usernames that are 7 or 8 or less should be fine. Greater than that, you're probably going to find problems. So we're not greater than that, we're fine. It's not going to skip this jump and go straight to wrong. It's going to jump over wrong. All right, let's go jumping over the wrong. And then we're going to move into the dword that is at ESP, a 2. Now let's just go ahead and follow that. Excuse me. Follow a dword and dump. Oh, right. I'm sorry. Put it at the top of the stack is what that means. Error. Like that option. Better at tearing apart stuff. And yeah, absolutely. Like the easiest way to learn this is not by studying, it's by jumping in. You know, if you get thrown in a river, you either learn to swim or you drown. That's how us rednecks learn how to swim. So we pushed a 2 onto the stack, and now we're calling this sub here. And this sub here, well, what do you know? This is going to do some stuff, I tell you what. I tell you what. And let's see, what's after this? Nothing. So we are here. Like we mentioned before, you can get to this call, but how? And you get to it from here. The only way to get to that call, move to, call this. Let's go ahead and hit F7 and watch it from within. And you'll see that we're going to be moving some stuff, doing some stuff, and then it's going to go ahead and do a rep stos b. And ECX is 0, so now we move to ECX, our name. put that on the stack down there, clear out EBX, move ESI, the FFFFFFF, move EDI, RECX, okay, there we go. And then we're going to jump on down to here, move ECX, ESI, that's our FFFFF, move EAX, EBP. Okay, so we're looking for a 0. It's going to do a repeat until it runs out of space. So there we go. We're once again calculating the length. We're going to compare EBX and ECX. Oh, now we're in a loop. Now what's this loop doing? Usually you want to take a look and see right here. It's going to be writing something to memory because you'll see that it's on the left hand side. It's not a register on the left hand side, it's a memory address on the left hand side. So if we go ahead and breakpoint right there and breakpoint right there, because that's going to be the jump, we'll hit run and we'll see that we're going to be writing a 4D or an M to this spot here. This is our second time through it, so let's go ahead and follow in the dump this address here. Not in disassembler. What are you doing? Follow in dump. There. So there we go. Let's go ahead and hit F8. You'll see that we put an M. We do this. Come back around. We put a D. Put an A. We put an M. And now we're down here. So we did a MDAM. So this whole routine right up here is for the first part of our serial, which is now referenced in a few places. It's even on the stack over here. MDAM. Okay. So we'll go ahead and continue forward. Don't mind my mouth. Sometimes it does that. I'm thirsty. Not a sponsor. Obviously. Clear those out, and then it's going to jump on down here, and it's going to start a new loop. Now in this loop, compare EBX with ECX. Of course, those are 0. It's below. And here we see another byte being written. Let's go ahead and put a breakpoint there, and a breakpoint past this. Well, let's hit run. There's a breakpoint. Here's a breakpoint. I bet you it's not too far from this one, and we'll see it here. We'll go ahead and hit F8, and oh, what do you know? It's right there. So we're going to continue through that. I'm going to hit F9, and MREM. MDAM, MREM. Okay, now hit run. We land here. Move EAX to that. Move EDX, our key that we put in. All right, now we are going to compare ECX and ECX. Don't know why, but it is, just to make sure that apparently it's not. Nah, who knows? Because that's not even being used. Now, our good friend REPE, compare SB. Now, if you don't know what that is, I knew we'd need olly again. Let's go to that address, and let's go ahead. See, this makes so much more sense in here, too. And now you can see what it does. Repeat, compare, ESI, EDI, and it makes more sense. We do help on command. It says searches strings for the first non-matching byte. So it's going to search through ESI and EDI until it finds the first non-matching byte. Good? All right. So let's go ahead and go through here. So it's going to search through ESI and EDI. EDI being this, follow and dump. Well, once we get down to it. Okay, so F8 there, moves into ESI, the little key that it made, moves into EDI, the key that we typed in, and now it's going to do this compare. Now, obviously, none of these compare. And watch our flags. Actually, let's do this. Snipping tool is our friend. Let's grab our registers and go like this. Put this over here, click here, let's hit F8, boom. Now if you missed it, guess what? We got it referenced right here. You'll see that Z is now 0, P is now 0, And this is all good still. But we have a 3 here, so the first byte did not match. You'll see that the first byte of both of those came off. This was decremented. And then we kicked out because it didn't match. So it didn't even go on comparing the rest of it. Oh, don't do that. Just come back over here. All right, so now that it didn't match, look, we're going to jump straight to wrong. Ouch. We don't want to jump straight to wrong. No, let's not do that. Let's just not. No. Let's just go ahead and do this. But you'll see that it's comparing MDAM and MREM. So, I mean, you could patch this and just tell it to always compare against itself. Move to ESI, EDX also. Or you could self-keygen it, which we can prepare for you. So that is all finished. We've done that. Let's go ahead and patch it for. Okay, so we are here. So now that we have calculated everything, we failed this, and you'll see that, did that patch everything? I don't think it patched everything. Don't think it did. Probably because we were on it, but those patches, yeah, these are all in there. Yep, they're all there. Okay, we're good. So, is that correct? Oh, yeah, we're good. We're good. I see what happened. So now, where it would normally be continuing on to say wrong, instead we're saying push that first part of the password. Okay, let's do that. Push that first part of the password. And then let's push the %s, because we want to print a string. Let's print that out. You'll see that now. Not there, but here we've printed MDAM. And then we're going to say go ahead and push that second part of the password, which is just from ESP plus 28. Of course, it moved. Up here, you'll see that it, well, yeah, you won't see it. But anyhow, we got that from right here on the stack. Right here on the stack. This would have been before we pushed it here, which is 1C and 2-0, so 1C, but then we pushed two things, which put it here, which makes this, oops, 2-8. And so we pushed 2-8 to get it, well, we will be pushing 2-8 to get it up there as well. So now we're actually going to overwrite the top of it, so we're good. And boom, now we've replaced that spot in the stack right here. It used to say MDAM, now it says MREM. Now we didn't have to do this part again because it's already there, but we did. We just left it because this would have normally been saying wrong, but now we injected our own spot to give us the first half and our next spot to give us the second half. What's cracking? Haha, I like it. Cracking the crackme that I wrote about 10 or 12 years ago that nobody has ever bothered to crack. And we're doing a self-keygen. Now, we put in fjlj, we put in a bad password, we've told it to spit out a good password, and we got MDAM, MREM. Let's give it a shot. Give it a shot. Is this it? fjlj, MDAM, MREM. Wrong. What? How's it wrong? We got it right from the program. Remember that time I told you that it gives you a different key if it's being debugged versus not being debugged? Let me show you. So let's go to patches, go to patch file. Let's go to, here's our real copy. We'll do Control-C, Control-V. We have a copy and it's number 2. Let's put keygen. Yeah, I want to replace it. There we go. Now we'll minimize all this stuff. Minimize that. Minimize that. We'll close that. To keygen, we'll type in fjlj. Type in a password. Oh, look at that. trqmdwtd. That's completely different. But fjlj. Here's the original program. trqmdwtm. Right. Ta-da. So, don't let it throw you off when you try to use your key that you found while debugging and it doesn't work. Because when you run it outside of the debugger, it will generate the right key if you do a self keygen. Now, if you try to keygen it yourself, you'll notice that sometimes you put in the key and the key changes over and over and over. Just flip, flop, flip, flop, flip. And that is a little maths trick. But like I said before, it has to do with the length of the name. For example, if we run to keygen and we put in universal, that's a UNIVERSAL. So that's 9. I don't think it will work, but we'll give it a shot. Universal, and that's data UKXCU TRUMNRXRS. Wrong. And that's because of the way that it rotates those, and it splits them into 2 spots and then compares against them separately. If we try just universe, that's 1 character less. Sorry, sometimes I freeze up. Universe. We'll see that they're very similar, but oh god. Universe. DAT. Notice there's no A here, but it's an MUKXC. There's no U at the end either. TRPMNRXR. I think this one will work, but it doesn't. Okay, is it 7? Let's try no E on the end. Try that. Universe. Universe. I had created another version where it only let you put in names like 7 or 6 or 7 long. I don't really remember now, but DATMUKX. Somebody's screaming at their screen going, "You typed it wrong!" Me going, I don't care. MNRX. Wrong. Maybe it's certain letters. I don't remember, but prove that more than just FJLJ works. I know radical works. Radical. TNS MMRX DWTM USX. RADI RADI 7 UNIV. I think it might have something to do with letters that aren't found, because it uses those 2 strings. The I wish I was good at reverse engineering, and you suck. So, and then it capitalizes them. So, RADI CA. Okay. There's no L, so that can't be it. Goes through. Basically just rotates through them for however many times you're, or the letter is. But let's see here. That is the intended solution outside of writing a actual keygen, which would give you the same results. Some names will work and some names won't work. So if you're wondering why your keygen doesn't work, that's why. Some will, some won't. Okay. DQ, BM. It may also have something to do with an overlapping buffer. I can't really remember. It doesn't work. CA2, 2, CA2, CA2, GNT, MJ, tut, T. Okay, that doesn't work. Force it to print right solve. Well, you could do that. Like I said, you can patch it. But if you want to write a keygen, you can do that as well. Now for patching it, that's very simple. Like I said, once you get to this section, it's not hard. Because essentially, you could just tell it binary edit, 0 there, and AMP here. Yeah, now, I mean, that will always say right no matter what you do. And in the real world, that would pretty much be what you would do because you wouldn't waste your time with a keygen that doesn't work for every name because the program doesn't allow every name. I don't remember my rationale for it back when I wrote it, and I don't remember the rules, and I don't want to dig into it because... But if I can find the source code that I originally wrote, then I'll expand on that. But don't have that one right now. Let's try Billy. Does Billy work? I think Billy works because it has that layout like Billy should work. Billy. Caps lock TR QMU DW TMU. Yay, Billy works. Like I said, it's strange. The most to learn from this crackme is getting to that point to where you can crack it, the anti-debugging tricks and stuff. Because also, if we were to rewind and just do a search for current module reference strings, you might think that some of these would be useful. Like here where it says name, pass, please register to continue, right, wrong. Well, no, these are the decoy codes. This code actually doesn't ever get ran, but our good fellow Blue Knight actually did do a patch where you put in a wrong key and it will say, wrong, your password is, I fell for the decoy. And then if we run it again, and put in I fell for the decoy, it will say right. And that's because he actually went ahead and patched it to where it comes into this code. And then here, it will just check against the I fell for the decoy, and it will jump if equal down to here, and it'll say wrong, or it'll say right. So he actually patched it to use the decoy code. And we can see that too. Let's take a look at it. I haven't actually looked and seen how he patched it yet, so Let's do that real quick here on live TV, computer TV. Kids these days with their high-fangled computer TVs. Okay, so we know that the code starts here, but we know that we end up in the decoy code somewhere. Let's see how we get there. Let's hit F8. F7. Unhandled exception filter. Get main arguments. Environment variables. And we land here. Okay. Call cracked. Okay. Get module handle A. Still doing this, which we want to go ahead and just skip over that. Origin here. Don't want to get stuck. Don't yet see how we've done it yet, but we'll see soon. Probably down here. Almost there. Hey, Red. Hey, Red. Hey. Yeah, can I get a Big Mac? Sorry. Okay, there we go. We're getting there. So, bum, 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 bum. Using alternate data streams on AFS. Yeah. Okay, so there we go. We're almost down to the decoy code. Okay, so instead of jumping to the real code, he's jumped down here where... Oh no, this is normal, I think. I think. Let's open up a side-by-side here of the original. Always taking the original with you. Copy address. Let's take the address. I don't know. Control G, V. All right. Yes. So definitely different here. So instead of continuing the unpacking sequence and then jumping back to here, we're actually going to just skip that and jump into right here. Let's hit F8 and see what happens. Where it actually comes in and loads everything. And then we have a call to the set unhandled exception filter. Everything's normal there. Okay, that's good. We have the check for debugger. We're going to return test EAX, jump if not equal, and this is going to go to there. So didn't patch out that, but this has definitely been modified underneath it a bit, because here's the sprintf. So we've noped that. And that call, because it causes an exception, got rid of the N3 and 3. Okay, so we want to not take this jump. And then go down here and see what happens. Move dword that. Okay, so we're putting that on there. He's gotten rid of the things that would cause exceptions. Call get last error for no reason, just because it was already in there. Now this is technically just decoy code. I copy and pasted and then just filled in some stuff. So it was, whether or not it was running code or not, runnable code, I didn't even remember. It was never meant to be ran. But let's see here. It obviously does, because it's going to say please register to continue, and then name printf and a scanf. But yes, this is just some decoy code here. And then it will ask and compare against the hard-coded password of I fell for the decoy. And it does that by doing stir. So yeah, it does. And you notice here that there's not even I guess there is a test that goes to a wrong. Wrong. Your password is I fell for the decoy. And that, I believe he just modified in the dump. Address. That's not it. Address. Value. Oh, Jesus, what the? Okay. Follow and dump. That one. Thank you. Wrong. Your password is I fell for the decoy. Yeah, so that's just been modified in the binary of the file there. Because this typically just says wrong. Follow and dump, that one. Yeah, wrong, and then he got rid of the I wish I was good at reverse engineering and replaced it with your password is I fell for the decoy. Which is definitely where, if you're just starting out, you'll see those things, you'll patch it that way, and that is a good learning experience. It has replayability. You go back and you try to get it the other way, and every time you're going to learn something new. So, well done, Dr. Blue. But yeah, I see what you did there. You ran the decoy code. You said, hey, let's just run the decoy code. Yeah, it's good. Good. All right, guys. So what did we accomplish? I know that Radical Raccoon actually is writing, or did write, a keygen for it. I haven't seen the actual keygen yet. I want to. Haven't yet seen it, but he was a little confused about the whole keys not working and changing on him for the name Radical Raccoon, which I can verify. Radical Raccoon, that key will not work. Verifiably so. This. That one worked. Billy works. Radical Raccoon. Oh yeah, that's a long password. ENS. You know, I can copy paste. Copy pasta. Wrong. Yeah. So that one doesn't work. But radical. Let's try just raccoon. Whoa. Of course, capital will definitely come out differently. Raccoon. PNG, MJV, DWT, mus. That's a ticker. Hey, raccoon works, radical works. You just got to run them separately, all right? Hey, whoa, can we do spaces? Right. Radical. Oh. Let's try it in caps. Raccoon. It took the pass as raccoon. Of course. So space, no. No space. Let's try radical raccoon. That works. So raccoon works, radical works, Billy works, FJLJ works. I think some variant of CA2 works. I don't remember. Name. Oh no, I don't need the keygen. Radical raccoon. Nope. Doesn't work. And let's real quick just go new. Actually, we can just leave it running. Have to do that. Let's run another one with Radical Raccoon and see if it gives us a different key, because I bet it will. TDB, MUXX, JDEBMN, DWTMUS, XQTM, not C, TMM. And does that one work? Let's see how many different ones we can get. Radical Raccoon. QTTTMM. TOTM. And OPQRS. Radical Raccoon. OPQ. TP, T, TT, TM, O, C. You notice that those all change every time by this character right here. Let's get rid of that character right there and make it or shorter. But essentially, if you can run the keygen and type in a name and get the same key for that same name twice, then it's going to be valid. There you go. So we can do CA2. QBT MQT. There you go. But if your name is one of those that has to grab one of the next characters because somebody made it an odd number or something, and don't ask. Off by one error is what I call it. Then your key changes, and that name's not valid. It's not a valid name. But you can make a keygen, you can make a self keygen, and the fun in doing it is actually getting there. You can also make a patcher, and still, if you get to the right spot to patch the actual checking code, not the decoy code, there's a lot of fun to be had there as well. You learn a lot of anti-debugging, and you learn a lot of anti-debugging tricks that I'm going to write a new one, and it's going to be a lot of fun. It won't be too difficult, but it's going to be fun. It's going to be difficult fun. Does that make sense? I hope it does. I've got to go. You guys are great. Quick, any questions before I take out? It is 1 o'clock, so I am running thin here. No questions. All right, fine. All right. Well, I didn't see any questions. If you guys want to send me anything, feel free to send it away. Send it on over this way. We will take a look at it. We'll have a good time. And if you would like an account for the awesome little server that we've got going on here, you get your very own desktop just like this. Let's see. Technically, I bet I could, but yeah. Is anybody else logged in right now? Nope, just me. But you'll get everything that's on here. 50 gigabytes of virtual of your own virtual hard disk, so you can unplug it, mount it, and download the whole thing if you'd like. That is stored here. Under your username, it's mounted when you log in, so if you're not logged in, it's not mounted. And yeah, if you want that, go ahead and pop in on the Discord. If you have any questions, pop in on Discord. This crackme is in the comments to be downloadable. And I will go ahead and end this video here so it doesn't get too long and where it's still relevant. And yeah, go ahead and send some things our way, my way. We'll work on them. We'll go over them. And until then, I'm going to be writing a new crackme that you guys are going to have so much fun with. And there's going to be a prize at the end. Oh yeah, big prizes, big people. Although if it takes 15 years, I'm sorry. Alright, we'll talk to you guys later. And thank you again for watching. I hope you enjoyed as much as I did. And we'll see you next time.